So let's solve question number 17 from the year October 2023. This question is from the chapter Fluid Mechanics. In the question they have said, scientists use weather balloons to carry equipment into the upper atmosphere to monitor weather conditions. So what they're doing is they are carrying equipments in the balloons into the upper atmosphere to monitor or measure the weather conditions. Okay, the photograph shows a weather balloon. Okay, this is the weather balloon and this is the equipment. They have says upthrust acts on the balloon is released and accelerates upwards. Okay, they have said what is meant by upthrust. We all know, suppose there are air, these are all the airs. When I immerse a balloon right here or right here, when there is a balloon right here, when there is a balloon right here in the air, these are all the airs, this balloon has displaced a certain amount of air. When it is in this position, it has displaced certain amount of air, because previously there was air in these positions as well, but as the ball has taken its place, or it has immersed here, it has displaced a couple of airs or a certain amount of airs. So it has also displaced these airs. The weight of this displaced air is equal to the upthrust force acting on the ball. The weight of the air which this ball has displaced is the force with which this remaining air will exert a force on this ball. So let's go and write it down in our own words. The answer will be a force equal and opposite to the weight of the fluid displaced by an object. We all know weight acts downwards and the upthrust force acts up. This is why the force is equal and opposite of the weight of the fluid. This is not the weight of the ball, this is the weight of the fluid displaced by the ball or the balloon. Okay, so let's move forward to the question number B. In the question number B, they have said when the balloon is released, the initial upward acceleration is this. So this is our acceleration. Show that the weight of the balloon and equipment is this. They have asked us about the weight of the balloon. They have asked us to find out the weight of the balloon. They have given us the volume of the balloon and equipment and the density of the air at ground level. As we all know, upthrust is equals to rho Vg. This is the density of the fluid, this is the volume of the solid, and this is the gravity. So we can find out the upthrust here. We have been given on the density, we have been given the velocity, and we all know the gravity. So we can multiply 1.23 into 1.63 into 9.81. The answer will be 19.67 Newton. We all know as the ball is moving upward, its upthrust is greater than its weight. So there is a resultant force upward. The resultant force is upward. So we can say, as they have given us the upward acceleration, we can use this acceleration with this force using the Newton's second law, which is force is equals to mass into acceleration. We know the acceleration is 4.8 and we all know the resultant force. As the resultant force is upward, we can say the resultant force is upthrust minus weight, as the upthrust is greater and the ball is moving upward. So we can say upthrust minus weight, which can be regarded as 19.67. This is the upthrust we have found out, minus the mass into 9.81 is equals to this mass into this acceleration 4.8. So we can subject this mass and find out the mass. The mass will be 19.7 divided by 4.8 plus 9.81, which will be equals to 1.346 kg. They've said us to find out the weight, so we have to multiply this mass with 9.81. We could have found out this weight, but as we don't know this mass, we have to convert it into mass into gravity to find out this both mass. We couldn't find out straight away. We have to find out the mass and then we have to again multiply it with 9.81. So we are done with question number B. So let's move forward to the next question. In this question they have said the graph shows, okay, so let's solve this question. They have said the graph shows how the density of air decreases with height above the ground. We know as the height increases, the density of the air increases, and they have given us the density and the height. The scientists want to make measurements at a height of 25 km where the balloon would stop rising. So this is our maximum height. The balloon will expand as it rises and will burst if volume exceeds 50 meter cube. This is the maximum volume up to which it can increase, and if it expands more than 50 meter cube, it will burst. They have said deduce whether the weather balloon could support the experiment at a height of 25 km. So basically they are asking is at 25 km will the volume be 50 meter cube or it will be less than 50 meter cube. If it is greater than 50 meter cube, then the balloon will burst. So let it write it down. It cannot be, the volume needs to be less than 50 meter cube, less than or equal to 50 meter cube. So let's find out the volume. We have to find out the upthrust. We all know the upthrust. We have found out here. We have found out the upthrust 13.2. So we have to find out the velocity. We know the formula of upthrust, which is upthrust is equals to rho v g. So we know the upthrust, which is 13.2 Newton. And we can use this upthrust formula to find out this velocity. We all know the density. We can find out the density using the graph. At 25 km, this is the 25 km. At this position, the density is will be, if this is 0.10, then this is going to be 0.05. This is going to be 0.05. So we can say 0.05 into volume into 9.81. We can find out using that to find out the V. The V will be 26.9 meter cube. As it is less than 50 meter cube, 26.9 is less than 50 meter cube. So yes, the balloon could support the equipment at a height of 25. So yes, the balloon will support. Okay, so let's move forward to the next question. In the next question they have said a weather balloon made of a strong material will rise and eventually stop expanding. It will stop expanding. So the velocity, so the volume will not expand anymore. The velocity will become constant. The volume will become constant. That is, it will stop expanding. It will continue to rise until it reaches a maximum height. It will continue to rise. The upthrust will, no, the upthrust, not the upthrust, but the upward displacement will increase. Explain how and why the velocity of the weather balloon changes from release until it reaches its maximum height. So we have to say about the velocity, how the velocity changes from the release point to the maximum height. We have to ignore the viscous drag forces. So Fd is ignored. So let's go and find it out. We all know, let's make it down right here. It is the release point. Okay, it is the release point from where the ball was released. So when the ball was released, we all know the upthrust was greater than the weight. That's why there is an upward force upward. The upthrust was greater, so there was a resultant force upward. There was an upward resultant force. Okay, there was an upward resultant force. But as it reaches its maximum height, as it reaches its maximum height, the upthrust is equals to, we know, rho Vg. In the question they have said the strong material will rise and eventually stop expanding, will continue to rise its maximum height. Okay, so the volume stop expanding. So we can say the volume becomes constant and the gravity is also constant. And this density decreases. This density decreases. This density decreases as the height is increased. We all know, as the height increases, as we grow, as we move upward and upward in the atmosphere, the atmospheric pressure decreases. So the densities in our surrounding will also decrease. So as our surrounding decreases, the upthrust will increase. So here upthrust was equals to the weight, but the upthrust will start decreasing. As the upthrust will start decreasing, the velocity will also decrease. As the upthrust starts decreasing, we all know upthrust is equals to weight. As the upthrust starts decreasing, the resultant force becomes in the downward position. As the resultant force is in the downward position, we know force is equals to mass into acceleration. But the ball is moving upward. As the ball is moving upward, but the resultant force is downward, so the acceleration will also be downward, or the acceleration will be a deceleration. There will be a deceleration. As there is a deceleration, the velocity will decrease. So let's recap it. When it was released, its weight and upthrust was in this position. The upthrust was greater than the weight, so the resultant force was upward. There was an acceleration upward and the velocity was increasing in the upward direction. But somewhere in this position, when it has reached its maximum height, its velocity becomes constant, and we all know density decreases at this position at maximum height. As the height increases, the density decreases. As the density decreases, the upthrust also decreases. So this upthrust decreases and the weight is constant. So as the upthrust decreases, our resultant force is downward, because the ball is moving upward, the balloon is moving upward, but the upthrust is decreasing. And as the upthrust is decreasing, the weight is greater, the downward force is greater, but the balloon is moving upward, so the resultant force is downward, as the weight is greater than this upthrust. As the weight is greater than this upthrust, weight is a downward force, so the resultant force is also downward. As the resultant force is downward, the ball will decelerate, because the ball is moving upward, but the resultant force is downward. The ball is moving upward, but the resultant force is downward. So the ball will starts to decelerate and the velocity will also decrease. So let's go and write it down in our own words. Okay, the first point that we are going to mention is when the balloon is released, the upthrust is greater than the weight. This is our point number 1. We have to mention 6 points. So this is our second point. The resultant force is upward. As the upthrust is greater, the resultant force is upward. So the ball will move upward. The ball will accelerate upward. We know F is equals to ma. So the ball will accelerate upward. The balloon accelerates upward. Okay, this is our point number 3. And in the point number 4, we are going to write when the balloon is at maximum volume, the upthrust decreases. As the height increases, because the density of the surrounding decreases. We can explain this thing using our formula. Upthrust is equals to rho into V into G. At maximum volume, when the volume reaches its maximum volume, it becomes constant, and this gravity is also constant, but the density decreases. As the height increases, the density of the surrounding decreases. So as the density decreases, the upthrust also decreases. The upthrust decreases as the height increases because the density of the surrounding decreases. When the balloon is at maximum volume, we can explain these things using this formula. So we are done with 4 points. So let's write the number 5 point. Until upthrust is less than the weight. We all know this upthrust will decrease and decrease. We all know the upthrust was greater than the weight, but at maximum volume, when it reaches its maximum volume, the upthrust will start to decrease, and it will decrease and decrease and become smaller than the weight. It will become smaller than the weight because it is decreasing and decreasing as the height is increasing. As the height is increasing, the density is decreasing. As the height is increasing, the density is increasing. So the upthrust will start to decrease, and as the height will increase, the upthrust will decrease. So the upthrust will be smaller than the weight. So the resultant force now is downward. Than the weight. So the resultant force is downward. The resultant force is downward because the weight is greater than the upthrust, and the upthrust has decreased because of the decrease of the density, and the density decreases because at maximum height the density decreases, the density of the surrounding decreases. Okay, so we are done with 6 points. We have to answer another point, which is, as the resultant force is downward, the ball or the balloon will decelerate or the velocity will decrease. Velocity of the balloon decreases to 0 or decelerates to rest. Right now you might have a question, why the velocity decreases as the resultant force is downward. We all know the balloon was moving upward, and right now the resultant force is downward. So when the balloon was moving upward but the resultant force is downward, it was accelerating when the resultant force was in the same position as its motion. But when the resultant force is in the opposite position, in the opposite direction to its motion, the ball will starts to decelerate or its velocity will decrease. This is the reason behind its deceleration. So we are done with question number 17. Thank you.